this is Britt Caswell with another example video. In this video, I'm covering example 1 from section 5-2 in the SavvasRealize Algebra 1 textbook. So the goal of this example is to understand piecewise-defined functions. And so what this example does is it starts by asking us how this absolute value function is related to a linear function. And so what I'm going to do is I'm actually going to be showing you guys what the graph of that absolute value function looks like. Ooh, I have a straight line tool now that I'm using Jamboard. Let's go ahead and use that, shall we? Alright, so here we are with a very rough sketch of a graph. Now recall that an absolute value function is a V shape. Okay, so it's gonna create a shape that looks kind of like this, and we're gonna hope it's fairly straight. Now, with absolute value functions, recall that the left side and the right side, they tend to match each other. They're symmetrical. Alright, now another thing worth noting here is that each side of that V shape is a line. Alright, so I'm going to add that in our notes here. Each side of the V shape is a line. Now here's what's cool about this. The right hand side, so the right hand part of the V right here, that is the same thing as y equals 2x. So if I just drop the absolute values, I get the right hand side. Now this side is y equals negative 2x. So when we drop the absolute values, remember it creates two lines. Or I'm sorry, it creates two equations, and one is positive and one's negative. So there's the positive and there's the negative. Alright, so what I would say for this example is that the right hand side of the V is the line with the same equation, but without the absolute value in it. Alright, so if you pretend like you have a linear function and just drop your absolute values, you might have to distribute if something's being added or subtracted in there. But then you'll get your right hand side of the V, and then you can just reflect it using symmetry, and you'll get the left hand side of the V as well. So then we have this idea called a piecewise-defined function. Alright, so what that means is that we're taking each side of the V and writing it as the equation of a line, and then we put it in this kind of notation. Alright, so I say f of x equals, alright, that's the same thing as y equals or any of our function notation. But what we do to make it a piecewise-defined function is we put a bracket. And what this bracket's allowing us to do is it's allowing us to describe the right-hand side of both of the equations in essence. So let's talk about the graph of negative 3x. Alright, so the negative causes the V shape to flip upside down, and the 3 causes a vertical stretch. So if I start at my vertex, so if I start at my vertex and I go down 3, I create this line. So we're going to write the equation of that line. Alright, that is y equals, and we know the slope is negative 3x, and our y-intercept is at 0, so I don't need to put the plus 0, I could just leave it that way. So that negative 3x is going to come here. So now this absolute value has another side, right? Because we always have that V shape. So we know that it's going to come down like this. Alright, now the equation of this line is y equals, we know the slope is 3, and our y-intercept is 0, so I don't have to put the plus 0. So this piecewise function is also describing 3x. So this is most of it. But if I didn't have the graph, right, if that was covered up, how would we know for which values of x I use the negative 3x, or which values of x I use the positive 3x for? We just don't know. So what we have to do is we have to define the part of the domain that is satisfied by each of these equations. So this blue equation, right, the blue equation is covering all the x values here to the right-hand side of the axis. So for everything where x is greater than 0, oops, need to change my tool from a colored pencil, or a shading. So for everywhere where x is greater than 0, it's going to work with the negative 3x. However, when I look at the red part of the line, all right, the red part of our v is covering everywhere where x is less than 0. And so that's the domain that I'm going to put down here. Now with these v shapes, we do also have to think about what about when x is equal to 0. All right, we need to describe that within our domain because there's certainly a value there. Now it doesn't matter if I say x is greater than or equal to 0 here, or x is less than or equal to 0 here, because either way, if I plug in a 0 into these functions, I would get 0 coming out. Alright, so in this case where they meet, it doesn't really matter. Although Savvas does a really interesting thing where they will put a circle there and shade it, and they'll shade it with whichever function they want you to go with. Alrighty, so there we are. That is example 1. Until next time.